This video covers Trig P.7 and Pre-Calc 1.6 notes. The concept for today is going to be graphing functions. We're going to start with just a basic x function, and then we're going to work our way up to the x squared, then x cubed, the square root of x, reciprocal of x, and then something called step and piecewise functions. The goal for you at the end of this video is for you to understand the basic shape of what we're going to call these parent functions. The most simple form of graphing a linear equation. The most simple form of graphing a x squared. So your goal is to be able to know what the basic shape of these graphs look like. Because what we're going to be doing, so you have an understanding of where we're going, is we're going to eventually be adding to these graphs. We're going to add some numbers into the graph which will shift the graph, or it will stretch or shrink the graph. And you need to know how these numbers will affect the graph. So for this lesson, we're just going to be talking about the basic form of the graph. Let's start off by thinking about a linear equation. What I know about a linear equation is that it will form a line, and the equation for a linear equation is y equals mx plus b. And what I have here, it says f of 2 equals 3 and f of 4 equals 8. So f of 2 is just saying when x is 2, y is 3. So it's a coordinate point 2, 3. F of 4 is when x is 4, y is 8. So again, another coordinate point. And remember, if I'm going to write the equation for a line, there's two things that I need. I need to know what the slope of the line is, and I need to know what the y-intercept of the line is. So let's first of all find the slope. Remember, slope can be found by taking the y values and subtracting them, taking the x values and subtracting them, and then dividing that. So I'm going to get negative 5 over negative 2, which will reduce down to a positive 5/2. Now to find the b, what I'm going to do is I'm going to plug in one of these x, y values. I'll choose this one, and my slope into y equals mx plus b. So y would be 3, because that's the y value of my coordinate point. M is 5/2 times 2 plus b. Algebraically, when I multiply these two together, the 2's will end up canceling each other out because it's really 2 over 1. And I just get 5. Subtract the 5. I get negative 2 as the b value. So now that you have those two pieces of information, you can write your final answer as just replacing the m and the b in the equation. So y equals 5/2 x, and then your b is minus 2. So when you see a x value in this, well, we'll look at this equation. When you see an x value that is not squared, so it has a degree of 1, that means you're going to have a line. When you see a x value of, for example, if we're talking about the squaring function, and make sure you write this equation down, y equals x squared, that means that you're going to have a parabola. So you need to know that the basic shape of a equation with just an x is a line. The basic shape of an equation with a x squared is a parabola. So let's actually take a look at this basic parabola. So here is the equation, y equals x squared. So I invite you to pause the video and take the time to graph that on your coordinate plane here so that you have the graph as well. Alright, so once you have the graph, if I'm asking you to come up with some information about the graph, if I ask you to find the domain, remember that's the x values, and the range would be the y values. So looking at this graph, which x values are working for my graph? Well, let's just focus on the positive values. So the positive values start here, and then notice that the graph is going out. And it appears that it stops right maybe around 4, but what I know about this graph is that it is constantly increasing here. So it's going to keep going out and out and out and out, and I'm only getting a small window of what this graph looks like. So I know that all positive x values will work, and also all negative x values will work. So we would say that the domain of this graph is all real numbers, because all x values work. Now the range, on the other hand, The range is asking you for what y values work, and notice that the graph is completely above the x-axis, so therefore it's going to be only these positive y values that are going to work. So y is going to be greater than or equal to 0. Let's talk about symmetry now. Where is this graph symmetrical? So I like to think about symmetry as if I was to fold the graph, which axis would I have to fold it along so that it overlaps? So I've got a couple choices. I could fold it along the the y-axis, or I could fold along the x-axis. Well, if I fold my graph in half along this y-axis, this part of the graph will overlap completely right here. So therefore, because I folded along this axis, and this red part comes over to where now the blue part is, right on top of the previous existing graph, it's symmetrical along the y-axis. Let's talk about the x-intercept. Well, the x-intercept is the place where the graph touches the x-axis. It's touching it right here at 0, 0. The y-intercept is the place where the graph is touching the y-axis, and again you'll notice that it's touching it right there at 0, 0 as well. So the most basic form of the squared graph is it has a x and y-intercept at 0, 0. And what we're going to eventually be doing, and not in this section, but as we progress through this chapter, is we're going to be moving this point off of 0, 0 and adding more to this equation. And you're going to need to know, by adding things to the equation, what effect it will have on the graph. So right now what you need to understand is that the parent function of an x squared graph looks like this, and it's going to be a parabola. Let's talk a little bit about increasing versus decreasing. Remember, we need to define it by the x values. So let's start over here at the leftmost side of the graph, and you'll notice that at the leftmost side of the graph the x value is way, way, way up here. And so that x value is going to be a negative infinity. So at negative infinity, it's actually not increasing, I apologize. At negative infinity, my graph then starts to come down here till it gets to 0, and then it changes and it starts to increase. So it's actually decreasing at first, from negative infinity to 0. And then, like I said, at 0, then the graph changes directions and starts going back up. So at 0, it starts increasing until it gets to a positive infinity. Remember, this is not a coordinate point. These are the x values where my graph is either increasing or decreasing. Okay, the next type of graph we're going to look at is the cubed graph, so y equals x to the third. So I invite you to pause the video and make this graph on your xy axis. Okay, so once you've drawn your graph, let's take a look at this graph. Some key characteristics of this graph is that it's going right through the origin right here. So we know that our x and y intercepts are going to be 0, 0 as well. So let's fill that in. If we talk about the domain of this graph, what x values are working, we'll notice that x values, the positive x values are working, and it's continuously increasing here. And then these negative x values are working as well. So we can say any x value that I put in here, whether it's a positive or a negative number, is going to result in some y value. So again, our domain is all real numbers. And also for our range, notice that both the positive y values the graph is existing at, as well as the negative y values as the graph goes down this way. So our range is also all real numbers. Symmetry here is that our graph is going to be symmetrical along the origin. Here's how I know that. If I was to fold the graph along this y-axis, what would happen is this portion of the graph would kind of come over and look like this. Okay, so it's not going to be symmetrical along the y-axis because when I fold it, it doesn't overlap down here. But then when I fold it down, if I was able to take the graph and fold it along the x-axis, now this part is going to now get reflected down here. So I have to do two folds, the x and the y-axis, so that means it's symmetrical along the origin. Increasing and decreasing, the leftmost part of the graph is way down here at an x value of negative infinity, and the graph is going up. And notice that it's constantly going up, so there is no decreasing portion of the graph. I shouldn't put an x there, I should put none instead. So my graph is constantly increasing, so we would say from negative infinity to positive infinity. Again, what you need to know about the y equals x cubed graph, or in other words the cube graph, is that it's going to give you this S-like shape, okay? And eventually we're going to start moving the intercept away from the origin, but know that if you have a degree 3 polynomial, it's going to give you this S-like shape. Okay, the next one we're going to look at is the square root function, so that is the equation y equals the square root of x. Again, you'll notice that I've graphed it over here for you, so please take a minute to pause the video and draw that graph on your xy axis. Okay, once you've done that, let's go over some key concepts here. Notice that the graph is starting right here at the origin, so our x and y intercepts again are going to be 0, 0. Again, we're talking about the most basic form of these graphs, so you're going to notice that a lot of these will have the x and y intercepts at 0, 0. If we talk about the y, or the domain, the x values that work, notice that the graph is only on the positive side of the y-axis. Excuse me, that's the x-axis. So therefore the domain would be x values that are greater than or equal to 0. If I'm not sure if it goes exactly to 0, 0, plug a 0 in. The square root of 0 is 0, so it does exist there. But when I put a negative number in there, like for instance a negative 1, that's where I get an imaginary number, so you notice that the graph is not existing right here at negative 1. The range, what y values work, we'll notice that the graph is completely above the y-axis, so therefore those are all the positive values as well. So y is greater than or equal to 0. Symmetry. So think about the folds. If I was to fold this along the y-axis, I would take this part of the graph and kind of reflect it over this way. So that's not symmetrical along there. If I was to fold it along the x-axis, it would just move this part of the graph down here. So it's not symmetrical there. And if I was to fold it along both, it wouldn't overlap as well. So this is the example. This is an example where there is no symmetry. So it's not symmetrical at all. Your graph doesn't always have to be symmetrical. Talking about increasing and decreasing values, so the furthest left x value is going to be a 0, and then notice that my graph is increasing after that. So it's never decreasing, and from an x value equal to 0, from an x value equal to 0, it's going over here in the positive direction all the way to a positive infinity. So it's decreasing from 0 to infinity. Okay, let's take a look at the reciprocal function. The equation for the reciprocal function is 1 over x. It's the reciprocal of x. So I invite you to pause the video, take a second to graph this. Understand when you graph it, this line right here does not exist, so don't actually put that vertical line there. It's just going to be the two branches that you'll graph. This is a vertical asymptote, so that does not exist in your graph, so please do not draw that. Alright, so once you've drawn the graph, let's talk about the domain. What x values are working? Well, all of these negative x values are working until it gets up here to a 0, and then all of the positive x values are working. So it would be all real numbers except for 0. So the way we can define that is x does not equal 0. And the range, on the other hand, is going to be exactly the same. Notice that the graph is existing at all these positive y values, all these negative y values, but not right here at 0, 0. So therefore, the y value does not equal 0. Symmetry in this graph, in this equation here, if I was to fold it along the y-axis, this branch would kind of come over like this. And then if I was to fold it down along the x-axis, it would overlap right onto this branch. So therefore, it's symmetrical along the origin. X and y intercepts, since the graph does not exist here at 0, 0, and this branch is hugging the y-axis and the x-axis but never touching, and this branch hugs the x and y-axis but never touches it, there is none. So there is no x and y intercept. Let's talk about increasing versus decreasing. So if we start at the very furthest x value, negative infinity, what our graph is going to be doing is our graph is going to be as close to the x-axis as it possibly can, and then it's going to be going down. And actually I'm going to pause the video and pick up on increasing and decreasing in part 2.